Alright everybody, let's look at this new problem. So we're doing two-dimensional superposition problems. So these problems could take a little bit of a time and there's a lot of steps to them. But once you get the hang of it, even though it takes a long time, there's a few steps, they're all pretty much the same. So let's try to get the hang of it. So 3 charges equal to 2.9 microcoulombs, again that's 10 to the negative 6 coulombs, are placed at 3 corners of a square, 0.5 meters on each side as shown. So we see there's one here. They're all going to be positives. They're all positive. And they are 2.9 microcoulombs. So it's 2.9 microcoulombs, 2.9 microcoulombs, and 2.9 microcoulombs. We also see that the square has there is a square of 0.5 meters on each side. So what that means is this is 0.5 meters. Over here to over here is 0.5 meters. Okay. Now what we want to do, in what general direction will charge 3 go? So this is charge 1, charge 2, and charge 3. So we want to know what general direction will charge 3 go. And when we think about this, we want to think of a few things. If we were to just look at these two here, this charge would push this charge up this way because they want to repel. If we were to just look at this one and this one here, this charge would push this charge to the right. So the general direction that this is going to be going in is northeast. So we know it's going to go somewhere in that general direction. I could put northeast, or I'm just going to draw like an arrow like this. Okay. Part B now says find the magnitude and direction of the net force on the charge. Okay, so now we want to figure out what this value is. And let me see, I'm gonna put it like this. So there's a few things we're gonna do with this. The first thing is we want to find out how much force this one is pushing on this one. So I'm gonna do this force of electricity of this one. And the next thing, maybe I'm gonna do this one in red. So in this one, we want to know how much this charge is pushing on this one. So I'm gonna say force of electricity of this red one. And maybe I'll put a 2 as well. So there's 2 forces acting on it, and we want to know what the total magnitude of all of these are. So I'm going to first find the force of electricity of this red one. I guess force of electricity 2. So force of electricity 2 is equal to K Q1 Q2 R squared, which is going to be equal to 9 times 10 to the 9th, that's K, Q1, which is this one here, 2.9 times 10 to the negative 6 coulombs. And this one here, 2.9 times 10 to the negative 6 coulombs. And then, and then they are a distance of 0.5 squared apart. Okay. So I'm going to put that into my calculator. Again, I wanted to say that the hard part of this is putting it into your calculator correctly. At least that's what I think. So make sure when you're doing that, you're taking your time and putting it to your calculators correctly. 2.9 times 10 negative 6 divided by 0.5 squared. And we should get around 0.303. So it's going to be 0.303 newtons. And I'm going to put that right here. This is equal to 0.303 newtons. And now what we want to do is we want to find the force of electricity of this one. And you might think when you're looking for that one, oh, isn't that just the same as the other one? It's the same exact charge, and this is a square, so shouldn't this be exactly the same? However, hopefully you're realizing that it won't be exactly the same. And the reason why it's not exactly the same is this distance is different than this distance. So what we first have to do is we have to figure out what this R is equal to. Okay, it's not going to be hard. We're just going to be using some Pythagorean theorem, pi 5 squared times 2, and then this. And we find that this is going to be 0.707. So R is equal to 0.707 meters. Okay, but we should know since this is further away, it should be less than 0.303. And let's figure out what that's going to be. So force of electricity 1 is going to be equal to K Q1 Q2 R squared. K again is equal to 9 times 10 to the 9th. And then we have Q1, so charge 1 is the same here, 2.9 times 10 to negative 6 coulombs. and the same 2.9 times 10 to the negative 6 coulombs. Again, since they're repelling, that's why they're all pointed outwards. And now this one is not 0.5, this is 0.707 squared. Now let's put that into our calculator. So 9 times 10 to the power of 9 times 2.9 times 10 to the power of negative 6 times 2.9 times 10 power of negative 6 divided by 0.707 squared, and we should get 0.151. So 0.151 newtons, and we can see that it is less than this one, and the reason it's less is because it's further away. Okay, so now we found out how much force is coming from this one and how much force is coming from this one, but now we have to combine both of them together. So once we've combined this, now we want to find what all the forces are in the x direction and what all the forces are in the y direction. So let's first look at this red one. We can see this red one is 0.303. So let me just do it this way, I guess. F1 in the x plus F2 in the x is equal to, and then F1 in the y plus F2 in the y is equal to. So now let's look at this one. F1 in the x is equal, we're not exactly sure what that's equal to. What we do know is, since this is a triangle here, this is going to be 45 degrees. So this 0.151 newtons is coming at a 45-degree angle. So let's find what the force of electricity is in the x direction and what the force of electricity is in the y direction. So I'm going to do 0.151 times cosine of 45, and this is going to be 0.107. So this is equal to 0.107 newtons. And I know a 45-degree angle is the same, so this is also going to be 0.107 newtons. So now when it says F1 of x, I know that F1 of x is equal to 0.107 plus F2 of x, and I see that this one in the x direction is 0.303. I'm going to do that in red, 0.303. And F1 of y, that's going to be 0.107 again. And then for the y, this one over here, force electricity of 2 in the y is equal to 0, because it's only going the x direction and it's not going up at all, so this is just equal to 0. So what we have here is this is going to be 0.41 newtons, and then it's going to be 0.107 newtons. Okay, so we found the total in the x direction and total in the y direction, and now we want to combine those two. So once we have we're not going to just add it up, because since it's a vector, we need to do something different. We need to find the total. So we know the total force in the x direction is 0.41 newtons, and then going up 0.107 newtons. Now what we know is the magnitude of this all. This is going to be the magnitude here, and then we can do some Pythagorean theorem. 0.41 squared plus 0.107 squared. And then our Pythagorean theorem should always be bigger than these two. So this one's going to be 0.42 newtons. Okay, now we have to find direction. So that's going to be our magnitude. But now we have to find direction, tan inverse. So opposite is going to be 0.107 divided by 0.41. And this will give us theta. So if we put that into our calculator, we get 0.107 divided by 0.41. We get 14.6 degrees. Okay, so it's 0.42 newtons at 14.6 degrees. Okay, and that should make sense. Dun, dun, dun. Okay, so now, give me 1 second. Pause. Alright, so let's try another problem like this, because it could take a few tries. If you want to try to do this on your own, and then you could kind of check for yourself how well you did. But let's look at this problem. Example number 5. So again, superposition question. Find the magnitude and direction. Find the direction and magnitude of the net force exerted on the point charge Q3 in the figure. So this is Q3. Let Q equal 2.4 microcoulombs and D equal 33 centimeters. So each side of this is going to be 33 centimeters. I'm just going to put it at 0.33 meters. Okay? And we see that this charge here is equal to positive Q This one is equal to negative 2q, this one is equal to negative 3q, and this one is equal to negative 4q. So what I'm going to do for this one here is I'm going to say this one is going to be equal to 2.4 microcoulombs, positive, and I'm going to put a positive just to make everything simple. And this one is going to be negative 2q, so this one is going to be negative 4.8 microcoulombs. This one is going to be negative 4 coulombs, so that's going to be negative 9.6 microcoulombs, and then this one is going to be 3, so that's going to be equal to 7.2. So it's going to be negative 7.2. And which way should I put that? I guess I will put it this way: negative 7.2 microcoulombs. Okay, so that's how it should all be set up. So when we're looking at this problem here, what I want you guys to do is I want you to we're focusing in on this charge right here. Okay, so we want to kind of look at each of them individually. So let's kind of first look at this charge and this charge by itself like that. What I want to do is I want to see that this is positive and this is negative. So this force is going to be going down towards it like this. I'm going to call this the force of electricity 1. Okay, and this one's negative and this one's negative, so it's going to be going away from it. And I'm going to make this one red here. So I'm going to say this one is going red, and I'm going to say force of electricity 2. Okay, this one black. And then let's use a different color here. We will use green. So we'll say this one is green here, and this one's negative, and this one's negative, so it's going to be pushing away from it. So this one is going to be going this way, and I'm going to call this force of electricity 3. Okay, so now we have to individually find each of these forces of electricity. So let's start with force of electricity 1, which is going to equal to K, Q1, Q2 over R squared. So this is going to be 9 times 10 to the 9th. Q1 is going to be 2.4 times 10 to the negative 6. And then Q2, so this one is going to be negative 7.2. So I'm just going to put 7.2. I just do the absolute values because I know which direction it's going to go. Negative 6 and R. So again, we know this side is 0.33 meters, but we don't know what this R is over here. So I'm going to use Pythagorean theorem to figure out that R, 0.33 squared plus 0.33 squared, square root of that, and we get this as 0.47. So this is going to be 0.47 meters. It's going to be 0.47 squared, and now we can figure out what this is. 9 times 10 to the power of 9 times 2.4 times 10 to the power of negative 6 times 7.2 times 10 to the power of negative 6 divided by 0.47 squared. Okay, so it's going to be 0.704. It's going to be 0.704 newtons. So what we know is this one is going to be attracting this one by 0.704 newtons. So I'm going to put this as 0.704 newtons. Now what I'm going to do is I'm going to find what's the force that this one is repulsing on that one. So I'm going to do again same thing. Force of electricity 2 is equal to K Q1 Q2 R squared. K is again equal to 9 times 10 to the 9th. Q1, I'm going to call that Q1. It doesn't matter if you call that one or that one. You're just going to be multiplying. But this one is going to be 4.8 times 10 to the negative 6. This is going to be 7.2 times 10 to the negative 6. And they are a distance of 0.33 meters. So 0.33 squared. And then let's see where we get. 9 times 10 to the power of 9 times 4.8 times 10 to the power of negative 6 times 7.2 times 10 to the power of negative 6 divided by 0.33 squared. And we get 2.86 newtons. Okay, 2.86 newtons. And we see that it's a lot more for two reasons. This one is a lot closer, and also this charge is a lot bigger. So we can see that this is more. This side over here is also just as close as this one, but it has more of a charge, so it should be even more than this next one coming up. So let's look at that. So I'm going to do that one in green. So what we see is force of electricity 3. Oh, let me just put this down first. 2.86. So this is 2.86 newtons. All right, so let's look at force of electricity 3. This is going to equal, again, KQ1, Q2, R squared. So this is going to be 9 times 10 to the 9th. Q1, I'm going to call this one Q1, is equal to 9.6 times 10 to the negative 6. This one is 7.2. 7.2 times 10 to the negative 6. And then, again, this is 0.33 away from each other. And now we can figure out what this is. 9 times 10 to the power of 9 times 9.6 times 10 to the power of negative 6 times 7.2 times 10 to the power of negative 6 divided by 0.33 squared. And we get 5.71. As we said, this one is going to be the largest. Okay, so now what we want to do is, again, we want to find what the sum of all forces are in the x direction and what the sum of all forces are in the y direction. I guess before we do that, so we can call this f1 of x plus f2 of x plus f3 of x, and then f1 of y plus f2 of y plus f3 of y. And what we can do with this is we can, since this is all in the x and all in the y, we really only have to figure out what this one is in the x direction and what it is in the y direction. And since it's a complete 45-degree angle, this is 45 degrees and this is 45 degrees, we know this angle is going to be 45 degrees. That being said, if this is 0.704, let's find out what the x and y is. So 0.704 times cosine of 45, that'll give us 0.49, pretty much 0.5. So this side over here would be 0.5, and this side over here is 0.5. Okay, so now that we know all that, let's plug it in. F1 of x is going to be negative 0.5 because it's pointed to the left. So it's going to be negative 0.5 newtons plus F2 of x. So let's do F2 of x is 2.86. Maybe I'll do that in red. 2.86 plus F3 of x. And we see that actually F3 is only going up. So this is just going to be 0. Now let's look at F1 of y. We see that this is going down 0.5, so it's going to be negative 0.5. And for the red, it's not going up or down at all. It's only going horizontal, so this will be 0. And then for the y here, I didn't put that, 5.71. So this one is going up 5.71. And now we can just put it into our calculators. Negative 0.5 plus 2.86. is equal to 2.36. Yes, of course, 2.36 newtons. And then this one is going to be 5.21 newtons. Now that we found the total in the x and y, let's make our final chart of it. So we have 2.36 in the x direction, and then 5.21 in the y direction. And now we want to find what the total is, the total magnitude. So I'm going to be doing Pythagorean theorem, 5.21 squared plus 2.36 squared. And then I get 5.72. So I get 5.72 as the magnitude. That's all of these are going to be acting on this, and it's going to be going it's going to experience a force of 5.72. And the angle, I'm going to do tan again. Opposite 5.21 over adjacent 2.36, and we get 5.21 divided by 2.36, 65.6 degrees. And what this is saying is when all of these are acting on this one, it's going to go in relative direction of like somewhere like this. Somewhere like that, with the force of 5.72 newtons. Okay, so when all of these are acting, it's going to go that way, 5.72 newtons. It's going to go 65.6 degrees, 5.72 newtons. All right, and that is supervision 2D. Next time, I'll be doing a little bit of harder version of these kind of problems.